Welcome to our internet classroom for A-level chemistry. Today's lecture is about deducing the formula, balancing chemical equations, using state symbols and balancing ionic equations. After this lecture, hopeful, you will learn how to write down the chemical equations correctly. Let us begin. The electronic structure of the individual elements in a compound determines the formula of a compound. The formula of an ionic compound is determined by the charges on each of the ions present. The number of positive charges is balanced by the number of negative charges so that the total charge on the compound is 0. We can work out the formula for a compound if we know the charges on the ions. The figure on this slide shows the charges on some simple ions related to the position of the elements in the periodic table. The form of the periodic table that we shall be using has 18 groups because the transition elements are numbered as groups 3 to 12. So, aluminum is in group 13 and chlorine is in group 17. For simple metal ions in groups 1 and 2, the value of the positive charge is the same as the group number. For a simple metal ion in group 13, the value of the positive charge is 3+. For a simple nonmetal ion in groups 15 to 17, the value of the negative charge is 18 minus the group number. The charge on the ions of transition elements can vary. For example, iron forms two types of ions, iron with 2+ and 3+ charges. Ions that contain more than one type of atom are called compound ions. Some common compound ions that you should learn are listed in the table of this slide. The formula for an ionic compound is obtained by balancing the charges of the ions. Here is an example. Let us deduce the formula of magnesium chloride. There are two kinds of ions in this substance, magnesium with 2 positive charges and chloride with 1 negative charge. For electrical neutrality, we need 2 chloride ions for every magnesium 2+ ion. Therefore, the formula is as MgCl2. Here is another example. Let us deduce the formula of aluminium oxide. There are two kinds of ions in this substance, aluminium with 3 positive charges and oxide with 2 negative charge. For electrical neutrality, we need 3 oxide ions for every aluminium ion. Therefore, the formula is as Al2O3. The formula of a covalent compound is deduced from the number of electrons needed to achieve the stable electronic configuration of a noble gas. In general, carbon atoms form 4 bonds with other atoms, hydrogen and halogen atoms form 1 bond and oxygen atoms form 2 bonds. So the formula of water, H2O, follows these rules. The formula for methane is CH4, with each carbon atom bonding with 4 hydrogen atoms. However, there are many exceptions to these rules. Compounds containing a simple metal ion and non-metal ion are named by changing the end of the name of the non-metal element to IDE. Sodium reacts with chlorine to generate sodium chloride, and zinc reacts with sulfur to generate zinc sulfide. Compound ions containing oxygen are usually ended with ates. For example, the sulfate ion contains sulfur and oxygen, the phosphate ion contains phosphorus and oxygen. When chemicals react, atoms cannot be either created or destroyed. So there must be the same number of each type of atom on the reactants side of a chemical equation as there are on the products side. A symbol equation is a shorthand way of describing a chemical reaction. It shows the number and type of the atoms in the reactants and the number and type of atoms in the products. If these are the same, we say the equation is balanced. Follow these examples to see how we balance an equation. Here is an example of the formation of water. Step 1. Write down the formulae of all the reactants and products. So, we write down that hydrogen reacts with oxygen to form water. Step 2. Count the number of atoms of each reactant and product. So on the left of the equation, we get 2 hydrogens and 2 oxygen, while there are 2 hydrogens and 1 oxygen on the right. Step 3. Balance one of the atoms by placing a number in front of one of the reactants or products. In this case, the oxygen atoms on the right-hand side need to be balanced, so that they are equal in number to those on the left-hand side. Remember that the number in front multiplies everything in the formula. For example, 2 water molecules have 4 hydrogen atoms and 2 oxygen atoms. Step 4. Keep balancing in this way, one type of atom at a time until all the atoms are balanced. Note that when you balance an equation, you must not change the formulae of any of the reactants or products. Therefore, we get the final chemical equation. We sometimes find it useful to specify the physical states of the reactants and products in a chemical reaction. This is especially important where chemical equilibrium and rates of reaction are being discussed. We use the following state symbols: S stands for solid, L stands for liquid, G stands for gas, and AQ stands for aqueous or a solution in water. State symbols are written after the formula of each reactant and product. For example, zinc carbonate, which is solid, reacts with hydrogen sulfate, which is aqueous, to generate zinc sulfate, which is solid, water, and carbon dioxide, which is gas. Balancing ionic equations. When ionic compounds dissolve in water, the ions separate from each other. For example, sodium chloride dissolves in water to form sodium ion and chloride ion. The equation is like this on the slide. Ionic compounds include salts such as sodium bromide, magnesium sulfate, and ammonium nitrate. Acids and alkalis also contain ions. For example, hydrogen and chloride ions are present in hydrochloric acid, and sodium and hydroxide ions are present in sodium hydroxide. Many chemical reactions in aqueous solution involve ionic compounds. Only some of the ions in solution take part in these reactions. The ions that play no part in the reaction are called spectator ions. An ionic equation is simpler than a full chemical equation. It shows only the ions or other particles that are reacting. Spectator ions are omitted. Compare the full equation for the reaction of zinc with aqueous copper sulfate with the ionic equation. In this process, the equation is rewriting in the form with charges, and then the spectator ions were cancelled. At last, we get the ionic equation, in which you will notice that 1. There are no sulfate ions, since they are spectator ions not changing in the process. 2. Both the charges and atoms are balanced. Chemists usually prefer to write ionic equations for precipitation reactions. A precipitation reaction is a reaction where 2 aqueous solutions react to form a solid, the precipitate. For these reactions, the method of writing the ionic equation can be simplified. All you have to do is 1. Write the formula of the precipitate as the product. 2. Write the ions that go to make up the precipitate as the reactants. Here comes an example. An aqueous solution of iron sulfate reacts with an aqueous solution of sodium hydroxide. A precipitate of iron hydroxide is formed, together with an aqueous solution of sodium sulfate. So the ionic equation is iron ions in aqueous reacts with two hydroxide ions in aqueous to form iron hydroxide in solid. As a summary, we have talked about deducing the formula, balancing chemical equations, using state symbols and balancing ionic equations, as well as some examples. Do not forget to subscribe to our channel. That is all for today. Have a nice day and bye.